Okay, this is part 4 of the Tycho tutorial. I am going to be covering plate solving. And so, as some of you may know, plate solving allows you to determine the right ascension and declination coordinates, which is very useful for actually submitting observations of the asteroid positions. So, to do that, I will go ahead and proceed with launching Tycho. And you can recall that the R3 directory now contains images that have been aligned and normalized. So I'm going to load these images into the program, and just like normalization, I can run plate solving from Tycho. Now, this plate solving routine actually has a dependency on a tool called astrometry.net. It is actually using astrometry.net local copy. So I have a way to configure the path to the installation of the plate solver, and so this is the settings for the plate solving routine. So basically you would provide it again with the path to your copy of the astrometry.net solver, and you would give it also some hints. If you know the plate scale of your imaging chip, then you can get a very nice tight bounds on the plate scale that you can feed into the tool. So in my case, the plate scale is about 1.65, so I chose 1.6 and 1.7, and I also chose a down sample factor of 4. I so far have never encountered a situation where I couldn't use a downsample of 4. So, okay, all these settings are valid for what I want to do, so I click OK, and that kicks off the process. So as you can see, it says, okay, there are 39 images. It just simply goes from one image to the next, and it determines the WCS, in other words, the World Coordinate System information for each image, and it inserts it into the FITS header of each image. And as you can see, okay, it looks like we got an error. So that's not a big deal. On rare occasions, I say rare even though it just happened now, sometimes the plate solver will fail. So I know my settings here are correct, so I'm just going to go ahead and kick the process off again. This time I'm going to skip the images that have already been solved. So I click OK. So you can see it skipped those first few images, and now look at that. It succeeded in plate solving the one that it previously failed. So if you get an error like that and you know for sure that you supplied the correct information, then my recommendation is to simply try again. Now, sometimes it will fail if, for example, you downloaded insufficient index files. What I mean by that is you did not download enough of the index files for the focal length of the instrument you're using. So again, it's a blind solver, so it requires some knowledge of the well, I'm sorry, blind solver meaning it doesn't require knowledge, but it still has to have some data to work with. These are called the index files that it uses. Anyhow, you'll see that this process, it can take a few minutes, just depending on how many images you have, but it is at least it's automated. You don't have to really tell it a whole lot. I tend to favor it over other ways of determining geometry of an image. So, okay, we'll go ahead and let that finish up here, and I'll pause the recording and resume it once it has finished. Okay, so the plate solving routine finished, and as you can see, everything solved okay. It did not have to abort or anything of that sort, and you can verify that the column here says that every image has been plate solved. Okay, so now we are ready to begin the exciting stuff, which is the synthetic tracking. So I'll see you then in the next video.